Hello, everybody, and welcome. My name is Tess Konovich, and I'm the Scientific Marketing Manager here at EarthShift Global. And we are pleased to have Sarah Coulter, the U.S. Program Director at Accelerating Circularity, here today as our Brown Bag webinar speaker this month. At Accelerating Circularity, Sarah designs and leads sustainability initiatives across the textile industry. With over a decade of experience, Sarah specializes in supply chain sustainability, technical program development, standards and certifications, and strategic partnerships. She holds a BFA in art history from the University of Kansas and an MS in sustainability management from Columbia University. Known for her thoughtful leadership and global perspective, Sarah shares her expertise regularly as a speaker, panelist, and facilitator. Welcome, Sarah.
Thank you so much, Tess. And thank you so much to EarthShift Global for having me today. I'm really excited to be here speaking with you all about quantifying circularity in our real world textile trials. So let's get started. I'm really excited to share this work that we did actually in partnership with ESG. And I'm going to give a little bit of background about accelerating circularity to help set the stage. For those of you that aren't familiar with us and our work, Accelerating Circularity is a nonprofit. We were founded in late 2019. And our mission is to build circular systems that turn textiles into new raw materials. And that's in service of our mission of a world in which textiles are no longer wasted. And the reason that we do what we do, and getting down to the basics, and I know you all know this, but I am obligated to say it. There's just like way too many textiles that end up in landfills. And these materials represent a huge loss of economic value and are in themselves polluters. And we all know that our resources are finite. And in order to live within planetary boundaries, we need to shift from a linear take, make, waste model into a circular model. So what we think about at Accelerating Circularity is creating systems from collectors, sorters, pre-processors, recyclers, manufacturers, and brands and retailers, pulling them all together to collaborate to create pathways that turn old textiles into new materials. We're shifting the textile value chain away from the traditional linear paradigm, which is what you see in sort of the top half of this diagram, where at the end of their life, textiles go to waste, towards a circular one where the materials can be recycled into new products. So connecting this top half with the bottom half that you see at the in red in the bottom half of this diagram. So simply put, adding recycled content to a product can create a pathway to circularity, but is not in itself circular without a next best use strategy in place for the products and materials. We need to do better than that. So we need systems. We need to create all of the tools necessary for change. And that's really what we do at Accelerating Circularity. So I want to illustrate this more by talking in depth about our system trials, which is the sort of flagship program that we were working on for the majority of our short life as an organization, and how those programs have evolved over the past 5 years into what we now call building markets, our textile-to-textile post-consumer programs. The approach we took with these global trials, which were formally initiated in their execution phase in 2021, was shaped by this systems focus and really had a very large scope compared with other trials that you may have been familiar with in the space. So while we understand that the work to commercialize specific technologies and processes is essential, our focus at Accelerating Circularity was really on, again, developing the whole system so that circularity as a whole could scale. So we structured this program in 4 phases geared towards fostering consensus and cohesion among every node of the system and among all of the participants. So the first phase was research and mapping. And that was a fairly long process where we did a detailed stakeholder mapping of all of the players in the textile to textile system to identify end users of textile to textile materials, supply chain partners, and those stakeholders who might not have been included in a conventional stakeholder mapping of the textile supply system for the full spectrum of post-industrial and post-consumer textiles. Ultimately, that involved the participation of more than 74 companies from around the world at all levels of the supply chain. That's collectors, sorters, pre-processors, recyclers, yarn spinners, fabric mills, brands and retailers, testing companies, and others. Some of the companies were vertically integrated and they performed multiple steps of textile production and recycling under one roof, and others were, standalone, just doing one piece of the puzzle. And within this framework, we sometimes working in sector specific groups and sometimes working in more supply chain focused groups, we identified challenges at various levels. We used input from all of this work to inform the creation of what we called system boundaries. So really outlining the ground rules of the program overall. So we set the parameters of each pilot program. So the program overall, such as like, what are our minimum recycled content targets for these post-consumer programs? So generally speaking, we were aiming for 40% recycled content, with half of that coming from post-consumer sources. We were going to document each change of custody, and that traceability was going to be transactional, not physical, just because of the nature of this being a trial. We were going to identify end-of-life pathways for each material we developed. We were going to try as much as possible to enable regional production to reduce GHG impacts. We needed to meet supplier MOQs, standard supplier MOQs, because our eye was always to scaling commercially, not doing small pilot capsule style collections. Again, we're about systems change. We're about commercial scale, mainstreaming these materials. So we wanted to be running standard volumes, and that meant meeting standard MOQs. That meant a few things for the ways that we had to work. We had shared spec packs across numerous supply chains. We had shared testing requirements. We had common testing baselines for performance and MOQs. We shared materials across products and shared orders that helped us meet those MOQs for the suppliers. And then we had progress gates, to ensure that the system functioned. So it needed to pass, such and such gate by a certain time, certain performance requirement, before it moved on. And we developed participation agreements that all of the participants signed, that laid out all of these expectations so that, the playing field was level, everyone understood what they were signing up for. And it was all clear and laid out in writing. So if there was confusion, we could always refer back to that and say, okay, this is what we all signed up for. So, and I'm going through this in a great amount of detail because it does come into play when we get into the LCA discussion. So the because of the challenges that brands and retailers face when sourcing outside of their qualified vendors, which was what we were asking them to do in these programs, they or their tier one suppliers, in this case, in these programs would issue a PO to satisfy their commitments to the program at the yarn or the fabric stage. And then at that point, we enabled them to take the material into their existing supply chain at the yarn or fabric stage for finished product manufacturing. But pooling those order quantities from multiple brand and retailer partners and sharing feedstock fiber yarn qualities across multiple fabrics did allow us to meet minimum order quantities throughout the supply chain and ensure that the materials could meet normal production standards and scale. And then we were able to cooperatively develop and source feedstock specifications for cotton, polyester, and man-made cellulosics for multiple yarns and fabrics. We had a lot of successes and challenges from each segment. So I'm just going to run through a couple of those just to give you an idea of some of the detail of the work. Ultimately, we sourced, I'm going to say, I think it's about 27, 28 tons of post-consumer cotton for these programs, and a little bit less of polyester for these programs. In the US programs, which are the ones that I worked on primarily, sorting for textile to textile feedstocks is a really new process. So it was a really sort of involved task, meeting that single, very stringent specification that we had developed collaboratively with collector sorters and recyclers early on, that was shared across all of the material programs that we were developing, was a heavy lift. It was a big ask of the collectors and sorters. Finding a vendor willing to meet that spec was really challenging. All of those feedstocks, ultimately, we sourced from multiple vendors. All of those feedstocks were sorted by hand with assistance from handheld or tabletop NIR scanners. And one of the big learnings coming out of that is that that only really adds value when it is done on an item level, when it's only used for QC, QA, and that results in unacceptable levels of contamination. That learning feeds into other future work that we later came to do. But just some of the things that were really valuable to us in terms of feedback into the system for future development as we think about scale. All of the pre-processing for these feedstocks was done by hand. On the fiber level, we wound up developing what we call the ACP blend, which is a 50% post-industrial, 50% post-consumer recycled cotton fiber. And that really, got the most development work and went into the majority of the yarns and fabrics that were developed in the program. On the on the cotton side, obviously, and also went into some cotton poly blended programs. And really the focus on the yarn and fabric side was making the largest possible volume of basic materials. And that really is to enable validation of system viability and also to enable easy adoption, right? We're not trying to make the fanciest, um, you know, trend products. We want to make basics that can become eventually running programs. So the cotton fibers were ultimately blended into 9 different yarns that were blended with one or more were blended with virgin cotton as needed and potentially other fibers such as man-made cellulosics or polyester as needed. There were a number of learnings coming out of that. I will not go into too much detail, but I will say that all of the yarns were accepted by their fabric mill partners for bulk production. And despite the fact that we met supplier MOQs, these were still quite small programs. And so sequential manufacturing meant that any delay meant that there was, quite a backlog. So, it is still very much batch production. We went into jerseys, denims, and canvas with these yarns, and the brands ultimately made a number of finished products, which I can highlight on the next slide. We were really pleased that all of the fibers passed RSLs, the fabrics passed the testing requirements that were set by the program and were deemed repeatable. So that was really great and set us up for our next phase of work, which is really scaling these programs. So some of the key lessons coming out of that work is that, really engaging a diverse spectrum of partners enables us to go beyond the proof of concept, the one-to-one proof of concept. It ensures interoperability, and it helps all of the players to set reasonable expectations because we all know who's who, what's what, and who's doing what. And it encourages collaboration and innovation. We also were able to really deepen understanding across the board of really the fundamental attributes of each relevant process and technology and what is appropriate in terms of the applicability of each of those processes and technologies and the considerations of each of those things. Establishing common quality and performance standards again allows us to operate efficiently and builds a framework for interoperability, which sets us up for future scale. So because the fabrics from these yarns, the fabrics made from the yarns pass the standard performance and quality criteria, we knew that the brand partners could market the finished products coming out. And we also learned things like, in denim washdowns, obtaining the lightest colors negatively impacts fabric strength. So designers need to take that into consideration, the trade-offs between your desired color range and the strength testing baseline. That's, not just designing for circularity, but designing into circularity. And so now there's a whole new, set of product developers, who are working with these materials that now have this insight that they can bring into their work in the future. Then strategically allocating materials and aggregating orders to meet all of those minimums helps us facilitate that transition into standard programs. So, we were also able to develop a wide range of yarns, including finer ranges than previously thought possible with mechanically recycled cotton, up to 26 singles in the US. And really, there was quite a bit of skepticism around that. So we were really excited with the results of that. And what you're looking at here is one of the denim programs that came out of this work. This is a Wrangler jean that they developed with us. The 40% ACP blend went into the warp. That's why you see the 26 total recycled content in the final product, because the recycled yarn was in the warp there. In the interest of time, I will now move on to how this relates to the LCI work. So a little bit of background on LCI, LCA work. So as some of you maybe are familiar with, LCAs are a methodology to evaluate the environmental impacts of a product over its life cycle. And it is, there are established methodologies for conducting life cycle analyses. There are several initiatives and standards that govern how these are done. But ultimately, what an LCA does is helps stakeholders understand over the life cycle of a product from the raw material stage through end of life, what the impact of that product is over multiple environmental impact categories, be they climate change, ecosystem impacts, human health impacts, or resource use impacts. It also enables us to identify which stages of that product life cycle are contributing the most to those impacts. So if we think about all of the production stages, I'm going to skip back a little bit on my slides. So if we think about the different stages of a product's life cycle, I haven't shown use and end of life on my little diagram here, but you get the idea. It also helps us identify which stage of the product's life cycle is producing or generating most of those impacts or having the greatest influence on that product's impact. Whether that's the raw material stage, the manufacturing stage, maybe it's packaging or, product use. We often see that the product use stage is the most impactful stage, or maybe it's end of life. So briefly, the steps of an LCA are to understand the systems based on what they are, what they do, and model those materials and processes. Each raw material component of a product, the processes to manufacture, assemble, etc. Add up all of those throughout the chain, and then there you go. So it sounds relatively simple, but it is in fact quite complex. I want to just add one last note about some of the basics of the LCI, LCA, is that one of the additional things that it enables us to do is, for our purposes, is to compare various modes of production. So, for our purposes, we're interested in circular products and how they compare with the production of um, conventional products. So that's one thing that I just want to mention at the top because we're going to come back to it. So our study was a screening type of LCA, and we used primary data from different sources. And there was a little bit of uncertainty in certain cases, as there often is in this kind of work. We are not able to share the specific data providers for confidentiality reasons. But what this study does allow for is for us to figure out where there are gaps in data, where there's high levels of uncertainty, and it it allows us to identify, as I mentioned, hotspots, allows us to do some modeling and things like that. So what this study is really good for is identifying where in the product life cycle the impacts are occurring, where we have the potential to influence reductions in impact, ID obvious changes to reduce impact, and maybe compare different modes of production that can influence impact. So advantages and disadvantages, modeling perhaps different blend ratios in the yarns we might want to trial, versus things that are maybe not a robust use of this type of study. We would not want to use this to publish anything to say definitively X is better than Y. We would not want to use it to develop any kind of eco label. We wouldn't want to use it for any kind of carbon footprinting exercise or anything like that. Really, no sort of public facing statements of any kind about environmental impact claims. It's really for modeling purposes. It's for helping to understand sort of theoretical impacts where we can influence things for trial purposes, to reduce or influence product development. So our motivations were really to qualify or quantify the impacts of the trials that we were running for our own internal research, and to identify how different recycling components contribute to the overall impact of those products, and to compare circular to linear models of producing the yarn. And that's really to sort of improve our understanding of circular textiles, because it is such a nascent area of mode of production. So to set a baseline of understanding for the environmental benefits of textile to textile recycling, and to identify hotspots in those supply chains. So I've just thrown a lot out at you that may be a little bit confusing. So on my next slide, I'm going to walk through it in a little bit more detail that may help you understand that. But first, I just want to emphasize what the gates of our study were. So our study went from collecting through yarn spinning. And the reason for that is because, as I mentioned earlier when I was describing how our trials worked, the brands and retailers had the option to sort of buy in at the yarn stage, well, yarn or fabric stage, but many bought in at the yarn stage. So it made sense for our purposes of our study to have that be the gate for this work. So I'm going to move to the next slide now. So what you're seeing here, and this is, you don't need to get too caught up in the details. There's more detail here than you really need to see. And this is really just for illustration purposes to help you understand that these trial models are for quite, in some cases, complex yarns. So for this 100% rPET yarn here, for example, it's 100% rPET, but it's got mechanical rPET and chemical rPET in it. And the mechanical rPET is a 50-50 blend of textile and bottle feedstock. So that's really potentially 3 feedstock sources, 2 processes going into that yarn at the end of the day. So that's the level of complexity of what's going into these models. And so it really is a modular kind of system that we're modeling here. Similarly, for this third line here, where it's a 60-40 recycled cotton and polyester yarn, the 60% recycled cotton is that 50-50 ACP blend, where half of it is post-industrial and half of it is post-consumer. And then the rPET is the 50-50 bottle textile blend. So 2 recycling processes, 4 recycled feedstocks. So I'm not going to linger too much on this, really just to help understand, like, there are a lot of components that are going into this. And then this is one of the process flow diagrams that Earthshift worked up to begin to map out each process and stage of each of these trials. So what you see here is, the flow of every material through every stage in the process. So the textile that goes to the sorting, manually sorted clothes, automated sorted clothes, pre-processing, bottles, PET chip, mechanical recycling, the blending, the spinning, et cetera, et cetera, et cetera. So a diagram of this nature was worked up for every single one of those trial models, and ultimately then developed into a tool that allowed us to iteratively pick various processes and blend ratios to dynamically model different yarns using various partner selections with circular and virgin equivalents to test variables and then see, modeled results of impact and how those choices would influence that impact. So I'm going to take you through now some of the results of that. So this is just very high level. So in one of our trial models, we had a 100% post-industrial recycled cotton. And in that model program of the 100% post-industrial recycled cotton yarn, across all of the impact categories, its impact was 45 to 70% lower than first gen material in that model. For water consumption, again, this is compared to first generation material. In a model where we used 60% recycled cotton, 40% recycled poly, that model that I was just walking you through, the water consumption impact was reduced by 90%. Yarn spinning This is an interesting one. Yarn spinning is a big contributor across all categories. That's in recycling, in the recycled impacts. But when you're using first gen cotton, its production has the most impact. And these three over here on the right bottom. So if we displace first gen cotton with 40% recycled cotton, we see water use and eutrophication go down 40% and global warming potential and abiotic depletion go down 20%. So these are just, examples of what we can do with the model that that ESG built up for us. And it's really exciting because they did so much primary research with our partners in terms of data collection, and then building up this model so that we are able to actually adapt the blend ratios and pick the partners and build up a model yarn to reflect choices for the trials that we want to make, and see how that influences potential impact. And so we were really excited to have this tool, and really have been happy to have a partner in ESG. So I can stop there and turn it over for questions.
Thank you, Sarah. Okay, what a lovely presentation. We're going to move into the Q&A now, so I'll be reading them aloud to Sarah, and you can put any additional questions in that Q&A tab at the bottom of your screen, everybody. So the first is more of a comment. So Sarah, I'll give you the opportunity to comment or provide your thoughts on this. So today is actually Overshoot Day, where we have consumed all the renewable resources that Earth can generate in a year. I don't know if you have a comment there, or we can all just acknowledge that.
Yes. Thank you for noting that.
Yep. All right, we will move on to question number 2. Was it difficult to ensure the added collection, sorting, and recycling steps did not exceed the CO2 impacts of virgin textiles? And then what did you do to ensure you could maintain a CO2 reduction of the recycled textiles? Oh, you're muted, Sarah.
I went to take myself off mute and something covered up my mute button. That's a great question. And let me actually go back to my little. So the collection and the collection, sorting, and recycling pieces and the CO2 impacts of virgin textiles, it's a really good consideration. And so without getting into too much detail, because of course the answer is it depends. We studied a lot of recycling technologies, and it depends on where those processes are located, what is the source of what is the energy source, where they're located, et cetera, et cetera. But a lot of it at the end of the day comes down to transportation. And so we did some modeling where transportation was and was not considered. And the biggest impact you can see here on this slide is this is the contribution. So transportation makes about a 10% contribution to eutrophication when considered, and otherwise it's really a marginal impact overall. Manual sorting has also a negligible impact. Sorting and pre-processing, negligible impact on any category. Similarly, the collection is really down to transportation. So we did model it, and ultimately it's really we're not seeing that the production of that the recycling processes are outweighing the impacts of virgin production.
Thank you, Sarah. And while you're on this slide, I'm going to skip ahead to the last question or one of the other questions that's about this slide. So based on the results slide, could you please explain what is meant by displacing 40% cotton? Do the results displayed on this slide account for the displacement of virgin cotton? And have you found any evidence of this?
Got it. Yeah. So just yes, to clarify, so this is about the tool that ESG built for us to model trial yarns that we might want to build. So if we are modeling, let's say, 100% virgin or first gen cotton yarn, and we wanted to model content where we reduced that to 60% first gen, 40% our cotton with our ACP blend that's 50% post-industrial, 50% post-consumer, then we would expect to see the results of those impacts go down by those amounts in our model results.
Thank you. Okay, so more on the results. So this commenter noted that the results of the this was about your trial, I'm sorry. So this commenter or question asker noted that the results of the trial LCAs are not being made public, but they are wondering if they are being shared with any of the brands or retail partners for the purpose of growing participation in the programs.
We have been sharing some of the results anecdotally with brand and retail partners. I think that generally it's starting to be more understood in the marketplace that particularly in the case of recycled cotton, that the impacts of mechanically recycled cotton are lower than first gen cotton. I think also it's generally understood that there's not enough information because the technologies are so diverse in the chemically recycled fiber space that there's just not enough information yet to say one way or another definitively about the whole huge vast bucket of chemical recycling that we can say this technology performs in this way, this technology performs in that way. But I think for sure when it comes to mechanically recycled cotton, we're coming to a general understanding of how that performs, and we're able to talk about that with brands.
Excellent. I am going to skip down. Lisa had left a comment about our previous question. So there is no displacement in the modeling. It is simply that you don't have to produce new cotton. The recycled cotton comes in free of burden using the cutoff method. So thank you for the additional context, Lisa. The next question, well, first from Mariana. Sarah, thank you so much. So I want to give you the thanks you deserve, Sarah. And then the question here is, seeing these numbers on this results slide, Mariana is wondering how brands or your partners react to them.
Yeah, I mean, generally really positively. Particularly the supply chain partners whose work contributed to this are happy to see results like this, and happy to have contributed to something that helps the T2T story advance. One of the challenges we have is that overall the industry is in a really tough place right now, and it's really not enough to talk about impact right now. Everyone wants to know, like, can you deliver this impact and make it cost the same as what I'm doing today?
Okay, the next question. Are you starting to get a feel for the minimum size of population, like generating post-consumer feedstock, necessary to make these new models viable? Or is it too early to say? This question asker is thinking of how several states will likely have to cooperate in order to support viable collections and sorting systems, as well as joint recycling facilities.
That's a great question. So I think what you're getting at with that question is the issue of aggregation of feedstocks. And I would say that we we have a challenge in the US in that um, management of waste happens at a hyper local level. And that's not going to change when it comes to textiles, no matter what the collection scheme ultimately shakes out to be. We're going to wind up with a similar type of sets of systems that we have for other kinds of managed recyclable materials. So we're starting to see interesting solutions taking place and interesting partnerships taking place, with pilot curbside collections happening in the Portland area, in the Philadelphia area, at large scale, with partnerships between Goodwill and major, solid waste collection entities. There's a lot of stuff happening with SB 707, which I'm sure you're all familiar with. Assuming that some of the eco-modulation incentives come into place, I think we'll start to see a lot of movement. The key there, I think, is not, is there enough feedstock necessary? Is the infrastructure in place to aggregate those materials? So I think we will get there. I don't think that we will have a problem around the minimum size of population. I think that we will see plenty of material generated. It's just a matter of, will the right players come together for aggregating it in the right place?
Thank you. Our next question is, can you share more about the allocation method used and how was the quality of the recycled material assessed?
Yeah, I actually, not being the scientist who conducted the LCA study myself, I unfortunately am not the best person to speak to that. But I know Lisa and Mariana are on the line, and maybe they could type out the answer to that or just jump on. But I can speak to the quality of the recycled material. So maybe I can speak to the recycled material assessment while they're doing that part. So the recycled material was assessed on multiple levels. So for cotton, it was, went through all of the typical testing that any cotton fiber would go through. So APHIS testing, for spinnability. Then, the yarn was tested again in standard performance testing protocols. And then the fabrics, again, as I mentioned at the very beginning of the presentation, we set baseline performance testing standards for fabric using benchmarked performance testing standards from the brands. So we collated all of their performance testing standards and set a common baseline that we used for the recycled fabrics there. So that's how we assess the quality of the recycled materials. In terms of the feedstocks themselves, we had a very stringent specification that we used, and we quality tested it. The recyclers, of course, did quality assurance when it was received. We did double checking of the fiber content when it was received by the recycler. And then, of course, before it went into yarn spinning, it was again checked to ensure that it was what it said it was.
Thank you, Sarah. And another thanks for the presentation. Oh, Lisa just commented, so I'm going to speak on Lisa's behalf here to answer the first part of that question. So other than using the cutoff method for the recycled material, we didn't need to allocate. And perfect timing, Mariana also commented on this conversation and wrote that allocation was applied following the cutoff approach for the input recycled materials coming in. Aside from transportation, they are burned free. Then all the impacts of energy use and other materials needed for doing sorting, recycling, and spinning are accounted for. So thank you, ladies, for a team effort in answering that question. And another question, Sarah, was the impact of recycling using recycled textiles, example, increased transportation, accounted for in the study. Did we answer that already?
I think we did.
Yes. Okay. Okay. I have a question for you, Sarah, and then if anyone else has another one, you can put it in the chat. We have a few more minutes. My question is, are you doing any LCA work now?
We are. So, in order to scale up our work, we are continuing to develop some of these programs further, and some of our brand partners have requested, impact data that they can speak to publicly, and so we are in fact commissioning full LCAs for a couple of um, for a couple of these products that we're developing in our building markets program. And those should be coming out by the end of the year. They will be for specific supply chains in our building markets program. One that involves mechanically recycled cotton, one that involves thermomechanically recycled polyester, and one that involves chemically recycled polyester. And those will be publicly available, full LCAs.
Okay, well, thank you, Sarah, for sharing all of your exciting work and your experience with us today. And thank you to the audience for all of your questions and being so engaged. And I look forward to next month. If you have any questions, Sarah, do you have your contact information on any of these slides? You can
I
find her on LinkedIn. That's how I found her.
it's just Sarah with an H at acceleratingcircularity.org.
Excellent. And thank you again, and everybody have a great day.
Thank you.